Math 140, week number 7, back for part 3 and the final version of final edition, normal distributions and bell curve. Videos 1 and 2 covered problems 1 and 2 from the homework. Problem 3, once again, we've got probability like before, but now it's in a chart. It's not using z-scores and so forth. You're going to solve this one. I changed the numbers a little bit. I changed the probabilities. But it's still the same idea. We need to find probabilities, but now from a chart. All right. So first thing I'm going to do is I'm going to notice it's talking about at least 2 people. Well, I can find the probability of 2 people very easily. But think about what at least means. At least means it could be bigger. It could be 3 people is at least 2. Excuse me. 5 people is at least 2, and so on. So I'm going to have to expand that to cover the whole, starting at 2, expand it to cover the rest of the group. Those are the probabilities I want. I add them up, I get 0.976. Write it as a percent if you like. Either answer is going to be fine for part A. At least means start at 2 and go all the way to the end. Part B, everybody. Well, go back to the original problem to figure out what everybody means. If you read the entire scenario, we're talking about 5 people. Everybody would represent 5, would be 0.193. I got the answer. I could write it as a percent, and it's that's it. No equations, no calculations needed. You just have to look it up. Part D, normal. What does normal mean? Well, if you saw videos 1 and 2, you know normal distributions have a bell curve shape. All right, that's great. How do I interpret this in terms of a bell curve or not? Well, what I'm going to do is I'm actually going to graph it on Excel. You can graph it by hand. You actually don't even need to graph it. You could just sort of sketch it in your mind, really. But if you graph these numbers right here, you get something looking like this. And you got to compare. You say, well, okay, this goes up and comes back down. So does this, but it's maybe not as symmetric. So you could say, yeah, but not quite, or maybe just say, no, it's not the same. Maybe it would be perfectly the same. This is a judgment call. You're going to need to analyze a little bit, but for instance, I would say here it looks normal, but is not as symmetric as the true normal curve. So you see what I'm doing? I'm sort of kind of there's gray area involved with the answer for that. Anyways, the very last question, part 4. You'll notice that I've got a lot of numbers going on. I got mean, standard deviations, test scores, a lot of stuff going on, and I'm talking about z-scores. And I'm talking about relative scores. So there's lots of stuff going on. First thing I'm going to do, change the numbers. All right. But the one thing I want to make sure is if you have a problem like this where I'm asking z-scores, but I just give you a bunch of information, means and deviations and so forth, and I'm asking about relative scores, Acrobatic gives a good summary of how to approach something like this, page 87. And in particular, you're going to see a formula like this. It's telling you how to get the z-score from all these measurements and all these mean and deviation, etc., etc., etc. There's your formula right here in Greek letters, but you know what? I'm going to change those Greek letters to X, X bar, and S. I think those are a little easier to digest, to process in your brain. Z is the z-score, X is your measurement, X bar is the average, we've seen that before, and S stands for your standard deviation. Okay, so Acrobatic gives you this formula. I sort of cleaned up the letters a little bit, but you get the idea. And what we need now to do is kind of do detective work. Look, go in here and find some numbers, plug them into the formula. All right, so if we're talking about Alex, I see he scored 1462. Well, that's his measurement, so I put it in for X. 1462 is his measurement for the test. Oh, sorry about that. And I put it in the formula. Let's keep going. We're talking about Alex. Okay, Alex took the GRE. So if the GRE, the mean is for 1200. Mean is the X bar. Put it in for right here. Okay, we're talking about GRE, standard deviation GRE is 300, so I put it in here. You see what I'm doing? I'm just mining through the problem, getting the numbers, putting them in the formula, and my calculator does the rest. So his relative score, his z-score, is 0.87. Lauren, well, we got his formula, we got his measurement. We could start to plug it into the formula and go on and get his z-score. I'm putting this ... because, you know what? I think you can understand the process. I'm going to let you take it away from here. But the main idea is you're going to take your z-score formula, you're going to put all these numbers into the z-score formula, and this number that you get out is a relative score. Alex, relatively speaking, scored 0.87. Lauren, relatively speaking, I'll let you figure it out, and then you just compare and to tell me who has the better relative score. 3 videos. There's a lot of math going on in week 7, but you're going to make your best efforts, and if you do have more questions, shoot me an email. And final reminder, the midterm exams, if I have your homework through week 6, then I've emailed you the password for that midterm exam. So make sure that gets taken care of. Any questions? Let me know.